Okay, we're going to be doing our science. We are now on lesson 2 in topic 4, so you should have your science book out, open to page 126, and also have a pencil with you. If you need to pause the video to go get those things, please do that. All right, you have already watched the video today with Bill Nye, the science guy, and he showed you all the different ways that the earth can change slowly. It was really neat to see those experiments that he did that showed the slow changes on earth, how wind can do it slowly and weathering can do it slowly. So that's what we're talking about today, the slow changes to earth. Okay, let's go ahead and begin reading. Get your fingers out ready to follow. Earth, movement, and mountains. Mountains are part of the surface of Earth. Mountains can be hundreds to thousands of meters tall. The land around them is sometimes flat. Mountains form when layers of rock deep under the surface of the Earth push together. This pushing makes the land rise up. Over millions of years, the pushing forms tall mountains. Okay, so what is it that causes the tall mountains? Okay, you should have said that it was the pushing of the rock that forms the tall mountains. And how long does it take these mountains to form? Okay, and you should have said that it takes over millions of years for those tall mountains to form. Okay, read about the mountains, how mountains form. Then look at the chart. Use details from these two sources. Tell why mountain forming is a slow process. So we already read the paragraph. Let's now look at the chart here. I have the Appalachian Mountains, and it's 300 to 500 million years old, and the Himalayan Mountains that are 55 million years old. So my first question for you is, which mountains are older, the Himalayan mountains or the Appalachian mountains? Okay, you should have said that the Appalachian mountains are older, much older. These ones are 300 to 500 million years, and Himalayan, well, they're only 55. Still pretty old, but not nearly as old as the Appalachian mountains. Okay, and so again, if this said to use some evidence to show how we know it is a slow process. So give me one sentence, one piece of information here from somewhere on this page that is evidence, it's proof that forming a mountain is a slow process. Okay, in the video you should have typed something like, you could have said this, over millions of years, the pushing forms the tall mountains. Or your other evidence could have been the chart showing the age of the mountains, because if it's that old, then that's how long it's taking that mountain to keep pushing up. So these are, any one of these three would have been your evidence. Okay, now let's look at a different type of slow change to the earth, erosion and deposition. There are slow changes to the surface of earth that can take millions of years. Weathering, okay, I'm not talking about the temperature of the weather outside. This is a little bit different when it's a verb like this, weathering, okay? Weathering is the breaking up of rock. Plant roots grow in the cracks of rocks. The roots can break the rock into pieces. Water and ice can also break rock into pieces. So we know that the plants, their roots can grow and then it breaks it because they're strong. They need room to spread out. So all these examples, the rock is breaking, okay? It's pieces of rock that is breaking in the weathering. Okay, erosion. Erosion happens when soil, sand, and small bits of rock are removed. Rain, snow, and wind cause erosion. People and animals can erode rock and dirt on a mountain when they walk on it. So we know you've gone hiking before. When you go hiking and you come home, the bottom of your feet are very dirty on the bottom of your shoes. They have sand and rock on them. You just caused erosion because you removed some of that dirt and rock that used to be on the mountain. Now it's on the bottom of your shoe. So people can cause erosion too, just by walking on it. But there are other things that can blow away the sand and the soil and the rock. We know wind can blow it away. And we know water, rain, and snow can cause that rock and dirt to be moved. Okay, and the last one, deposition happens when wind and water drop sand, soil, and small bits of rock in a new place. Rivers drop most of these materials at deltas. These are places where rivers flow into the ocean. So we read when we were learning about rivers, how rivers can move the rock and the dirt. When rivers move that rock and dirt, they place that sand or rock or dirt or soil, whatever it is they're moving, they place it along the edges. And so that's when we get deltas. It's all that sand and dirt that has been moved by the river and placed somewhere else. And that begins to pile up. Okay, let's see this last question here. Tell how ocean waves cause erosion. They didn't talk about ocean waves here, but let's think about it. When you've been to the beach and you've seen the ocean waves, what do the waves do? Okay, so the waves cause erosion because it's moving the sand. Every time the wave goes up onto the beach, it moves the sand away with it. Tell why it can be important to prevent it. So if we know that every time a wave goes up on the beach and it takes some of that sand away and moves it down, why is it important to try to stop that from happening? Okay, you probably should have said something like, if all of that sand over time keeps getting moved away, the shoreline's going to get smaller and smaller. And so all those people who have those houses along the beach, eventually the shoreline's going to move back and back and farther back, and it'll go up into their house, and then they won't be able to have a house there anymore because it's going to be water right there. So we try to do things to prevent that from happening too. Okay, you are now going to do the interactivity in your science in Pearson Realize. And then after the interactivity, you're going to take the lesson quiz to see how much of this you remember and understood.